Oke, tadi baru aja kita saksikan presentasi yang ketiga berarti dan masih akan ada dua lagi yang akan disampaikan. Gimana nih Pak? So far, we're getting into it. Udah mulai memasuki dan udah ada mulai kelihatan big picture-nya dari ya.
Mestinya sih.
Mestinya.
Ada dua hal. Bisa ngerti atau nggak ngerti sama sekali.
Bisa ngerti atau mulai mumet. Udah mulai masuk ke yang mana nih?
Ya masuk yang mana nih? Udah makan siang,
makanya,
udah ngantuk.
Daripada mumet, makanya boleh ditumpahkan, dicurahkan unek-uneknya melalui live tweet gitu kembali ya.
Ada apa? Ada hadiahnya
live tweet, karena nanti jangan lupa ini masih jalan terus dari tim kita juga pastinya masih mantau terus live tweet dari kalian semua. Jangan lupa once again pastinya untuk disertakan juga ya hashtagnya. Dan pastinya untuk kalian semua yang udah live tweet boleh loh kalau misalnya nggak cuma foto-foto tapi mungkin pengen sharing sedikit mengenai isi daripada konten yang juga udah disampaikan. Kalian sekaligus sharing dengan teman-teman media sosialnya. Sharing is caring, right?
Betul.
So anyway, once again jangan kemana-mana, jangan pulang dulu karena tentunya nanti di akhir semua prestasinya udah beres kita nanti akan mengumumkan siapa yang menang ya.
Betul. Feeling saya sih yang session barusan agak lumayan berat. Ya, tapi itu yang sekarang lagi sangat-sangat populer ketika semua prinsipal mau lari ke machine learning, artificial intelligence. Ini buat kita juga satu insight ya supaya kita bisa lihat future-nya seperti apa. Tapi abis ini mungkin sesuatu yang jauh lebih familiar buat teman-teman semua, yaitu mobile device ya.
Mobile device. Nah. Udah mulai ada yang semangat tuh topik yang lumayan agak ditunggu juga. Oh ada juga dari belakang sana. Wah artinya masih semangat. Boleh lah ya.
Oke, mungkin ini lebih sehari-hari ya. Ada yang build application di Android, ada yang build application di iOS dan juga ada yang build application di Windows Phone ya. Jadi nanti mungkin akan dibawakan oleh presenter yang satu ini. Oke,
langsung saja kita akan mengundang, ini juga salah satu expertnya juga yang sudah kita undang. Ini adalah Technical Evangelist Microsoft India. Kita undang Mr. Abhishek Narain.
Abhishek Narain.
Good afternoon. How are you today? Looking good, right? So, looking excited joining us today.
Absolutely. Hello everyone.
Kenapa jawabnya malu-malu gitu? Coba ulang one more time probably.
Hello everyone. It's a pleasure to be here.
Okay.
So, from the morning itself, we already have the cloud. We already have the mobile web. And we already have a big data and analytics. So you are right now, we're delivering the mobile, how to build the mobile application and deploy it into the different places. Could you tell more about it?
A little teaser was interesting.
Yeah, absolutely. So in case, imagine you have a great app idea, which can probably make you as big as Facebook or a Twitter, next gen future apps, social apps, or it can be an enterprise app as well that you are planning to build for your enterprise. So in this next session, we are going to see how easily can you actually start from the building stage to actually managing the code base and then ensuring all the bugs and stuff that you get by the users, you can easily fix them as well. So this whole DevOps cycle for a mobile application is what we're going to see.
Okay, so it's starting from building sampai dengan maintaining berarti ya. Jadi kita akan ngelihat lebih lanjut dan mudah-mudahan tentunya ini akan memberikan insight yang lebih juga. Dan kayaknya di sini mungkin udah nggak sabar, mungkin jadi topik yang juga lagi in sekarang. Pastinya because I'm very sure that a lot of you right here, mungkin semuanya di sini sebenarnya di otaknya masing-masing udah punya ide untuk app yang kayaknya sih kelihatannya menarik gitu, tapi sebenarnya parameter untuk mengukur apakah menarik itu bisa diterima sama orang banyak itu seperti apa sih, aplikasi seperti apa sih yang beneficial, yang kita pikir bagus tapi apakah juga bagus untuk orang banyak, apakah beneficial juga untuk orang, seperti apa kita harus buildnya, and of course maintaining it supaya our users juga feel convenient using it, ya kan? Okay, so I'll let you do it. So right now kita kasih tepuk tangannya sekali lagi to Mr. Sheikh. The
Thank
stage
you.
is yours.
Thank you. Great, guys. So let's get started with a few demos. Actually, we'll get into the demos. This talk is going to be about building cross-platform apps, right? So I'm not going to talk about specifically Windows apps. How many of you use Android phones here? Android users? Android users? And how many of you use iOS? iOS? Yep. So now we'll see, as a Microsoft developer, how we can actually create the awesome apps that we would create for Windows, actually, to run those apps on Android and iOS as well. And what we are talking about is not a bridge. We will do native apps, right? So you can absolutely write a native app and generate an APK file, and then deploy that on the App Store and let the users use it. And it's going to be all native. It's not going to be like a Cordova app that you would do, which uses a web view. And that's the whole point of this session. And this is the tool that we would use, Xamarin. Now, the cool thing about Xamarin is it's open sourced. It's available for free now after the acquisition that Microsoft did, which means now with Visual Studio, say Visual Studio Community Edition, which is absolutely free for students, which is free for startups, less than a given number, and you can get started with creating native mobile apps and deploy it on store without having to pay a single rupee. And it's all open sourced framework, which means if you want to use open source framework to build apps, Xamarin is the solution for you. And here are my coordinates. I'm on Twitter. If you guys are on Twitter, you can follow me. And that's my email address. If you have any questions post the session which you would need to drop a mail to me, you can absolutely drop a mail to me. OK, so this is what we're going to talk about with Xamarin. The whole DevOps of a mobile app. And till now, enterprises, whenever I go to an enterprise, I see they want something like a framework that they would use, say, a Scrum kind of a thing, or an agile development technology for mobile apps as well. Because till now, mobile apps hasn't got that much of attention. I mean, it has from the consumer side, from the business enterprises side, it's catching up, right? And a lot of enterprise code is already available as a website. Say your internal expense app and stuff like that. Those are nothing but ASP.NET applications. Or there are a lot of C# Windows Forms applications. People did it like a decade back. Now, how do you leverage those source code to create a native mobile app for Android and iOS? And that's where we start with Xamarin. So I'll show you how the Xamarin code looks like in the demo. But we are going to cover from the dev to test. Xamarin also offers a testing solution, which is known as Xamarin Test Cloud. And what this does is they have more than 2,000 devices on the cloud. And the common issue with, say, any Android app is I'm not sure about whether it'll work well with a particular device, say Xiaomi's a particular phone versus Nexus versus there's so much of fragmentation there, so many manufacturers there, that I'm not sure whether my UI breaks on one or not. My performance goes for a toss on a particular Cyanogen mod-based operating system and stuff. So these are common issues that as developers, while we create an Android app, we face. So with XTC, you can absolutely test your iOS apps and your Android apps on the cloud. We have more than 2,000 devices there. So you can actually select the type of devices that you want to test, or you can actually test it on all the 2,000 different devices. And then it'll give you an automated result regarding the performance of your apps and a lot of more details, right? So that's the test cloud. So it uses NUnit test in case if you have used that before. You can write your NUnit test cases in C# or Calabash, which is again an open source framework. If you have done testing before, you would know about that. And you can actually use those scripts to actually run it on XTC with your deployable file might be an IPA for Apple, might be an APK for Android. Now that's Test Cloud. Next comes, I develop an app, I test it out, automate the testing part of it, which is good. And I would want to do a build automation or a continuous integration as well. So if I'm a team of developers, imagine scenario with the enterprise, might be 20 people from different teams working on it, one guy working on a particular logic in an app or a feature of an app, other guy working on different pieces of things. Now, each one of them, if you check in your code, what's probably the way to go forward? So Git is a very good example how people work in teams, and it's completely open source. So you can absolutely use Git with Visual Studio Team Services, not just for your enterprise web apps or any app. You can use it with Xamarin as well. So while you do a mobile app development, you can use Visual Studio Team Services, and then create a build spec over there within the Visual Studio Team Services and specify what you want to build. You can build Xamarin, you can build Java apps. Basically, VSTS is completely cross-platform, so it's not dependent on Visual Studio. Even if you're doing maybe a Java-based web app, you can still use VSTS as a code repo for automating your tests, cases, and then configuring your release environment and stuff like that. So VSTS can be used with anything. It can be plugged in with your current enterprise web app, or it can be plugged in with your mobile DevOps cycle as well, right? We will see this as well. How interesting and quick would this be, building this app on VSTS and then deploying it? Now the next question is, while you build a mobile app, web app is very simple. I can use a staging website and then push this guy over there and ask my QA guys to test it, right? That's how the web works. In mobile apps, I can't keep updating the app on the store. iOS is going to take some time to upload that app on the store and then make it available for people. So I would probably want to do some beta testing and stuff like that within my internal users and so on. Or even if it's an enterprise app, I can as well use Hockey app to distribute it for all the mobile devices which are registered with my Hockey app account, right? So it's very easy to create a Hockey app. That's another acquisition, so that's acquired again by Microsoft, a third-party company, which lets you distribute your app. It also lets you get the crash reports and stuff that generally happens with the mobile app, right? So we will see that, how you would plug in Hockey app with this whole DevOps cycle where I can do a continuous integration of builds. So the moment I check in a code, should go up to the cloud, build it there, generate an APK file, and then push that APK, release that APK file to Hockey app, which makes it available for each guy. So sends a notification to each of those users that there's a new version of the app. So you don't have to go to the store. You download it through the Hockey app, the newer version. You don't have to make it MDM compliant and stuff like that, which is the coolest part with the Hockey app. And then you get to monitor it as well. So all the crash reports, analytics of where the user is accessing within the app, what kind of methods, if you want to specifically keep a hang of what he's using in the app, you can absolutely log that back to the Hockey app. So that's the whole DevOps cycle that's we're going to see. Let's start with Dev. And a little bit about mobile development in today's world. How many of us have developed an Android app on the store? Android developers? Okay, which means to say, after this talk, all of you guys can actually develop an Android app and put it on store. So that's going to be a takeaway out of this session. So in today's world, this is what happens. People who develop Windows app, they only develop Windows app. People who develop Android app, they only develop Android app. Now, the problem with this is there's no code sharing. So if I write an awesome business logic, I got to retranslate that business logic from Objective-C to C# to Java, whichever platform I go in, because I can't copy the same code and paste it in another platform. That's the issue over here, which means your team needs to learn like all the native languages for supporting each of those platforms. So you end up having multiple teams for each, which is in a way, additional cost to your company. The other approach right now to run it everywhere is using Cordova. Many of you would have known, it's again open sourced. And Cordova uses your JavaScript. It has a JavaScript native shim, through which you can actually call the native APIs through the JavaScript, and it kind of abstracts the layer, so you get a, say, cam capture that works across Android, iOS, Windows, all the platforms. So you can go that path as well if you are coming from the JavaScript world. It's easier to use, but it suffers from performance. It also doesn't expose all the APIs. For example, if you want to use a 3D touch on an iOS while you build an app, there's no API or a plugin available, maybe today. So it's going to come up later on. So you always don't have 100% API accesses across while you go with this approach. With Xamarin, you solve those issues. So all your code base is in C#. So as long as you're comfortable with C#, this is probably one of the best ways you can create a mobile app. And it's 100% native API access. So any API that you would call from Java and Android app, or from Objective-C or Swift in your iOS app, you can call that here as well with Xamarin. And it's certainly high performance, right? So what you do is you share all your code in a portable class library here. So you create a class library, add all the logic, say, your HTTP requests, because you're going to use the same system.NET across all the 3 platforms, because it uses Mono to actually run all the .NET base class libraries across all the 3 platforms without affecting the performance of your app. Okay, now with Xamarin, there's another framework known as Xamarin Forms. So while you get started with Visual Studio, while I show you, you would see something as Xamarin Native iOS, Xamarin Native Android, and then something called Xamarin Forms. So Xamarin Forms is nothing but a UI toolkit or a UI library that these guys have written to ensure that you write the UI code and share it that as well across platforms, which means to say that I use a carousel control, and that carousel maps itself to a native carousel on iOS, native carousel on Android, native carousel or a tabbed kind of a page on Windows, right? So you just get to write your UI code only once in a portable class library, and you can build your APK, IPA file, and your ZAP file, and your Windows deployable files, Apex files. So you can build all of them just writing a single UI code, which still transforms to native UI. So it's not bad in performance as you would get when you try and use Cordova over there. So that's Xamarin Forms, right? So when to use when is if you want to do a rapid application development, you would certainly go with Xamarin Forms. But if you want to give a lot of native experiences, customizations per platform, say I want to use a different layout in Android versus an iOS. Since this guy is going to map it to native controls, your layouting will look alike, right? If I want to customize that per platform, because whatever the reason may be, in that case, you might want to go with Xamarin Native, which is Xamarin.iOS and Xamarin.Android. But if your whole purpose is to do a rapid app development, Xamarin Forms works out real well. So you can do 100% of code sharing across 3 platforms. So earlier, if you used to write, say, 3,000 lines of code for 3 apps, now you got to write 1,000 lines of code, and that works across all the 3 apps, and your apps are still native. Now, this is the whole cool part. Since morning, you might be seeing a lot of open source word being used in the event over here. And the truth is, like, almost everything is open sourced here. So from the server technology, ASP.NET Core is open sourced, right? Which means earlier, if you were using Mono over Linux, you can still use today a website. You can make it run on Linux or Mac using the Core CLR, right? That's the .NET native or the new .NET that we are coming up with. So now with the Core CLR part, all your server-side logic that you have written, you can bring it as it is, even to your apps if you wish to. That's the beauty here, because everything from your server to your client is running C#, C#, C#. So as long as it's the same language, you can absolutely bring it as a portable class library within the app, if the need be, right? So you can see iOS, Android, Windows, even all the services, managed services on Azure would support C#, which means my whole development lifecycle can live with C#, and I can still get to use all the open source frameworks. Nothing can be better than that. And this is the cool part. Xamarin is included in Visual Studio after the 2015 update 2, which makes it, this is a stat which the Xamarin folks gave. The number of customers that they had built over the past 3 years of their existence, they had 3.5 times multiplied the customer growth once they were acquired by Microsoft. So now you see how the traction for Xamarin has increased globally, because now people really trust Xamarin, because it was an indie startup company earlier. Now it's part of Visual Studio, so people tend to trust more those companies, and hence the traction for Xamarin has gone real lot, right? Which also means that Microsoft is going to fully support that. Any bugs that Xamarin framework has, we are going to fix that as well. So it's a great tool to use in the future. From now, whenever you build an app, you can always consider Xamarin as a stable platform to build your apps on. It's native, it runs everywhere, and it's open source. This is where you can actually find more details. If you want to contribute to Xamarin framework, for example, develop a plugin, third party, which is not available yet, or if you have a new API, for that you want to write an SDK and host it on the Xamarin component store and get paid for it, you can do that. So if you want to contribute in any means, you can find those details on open.xamarin.com. Now, C# runs on 2.6 billion devices, right? So that's the truth, which means now if you want to think about learning C#, probably this gives you a fair idea about how well-versed C# is. Now you can write Mac apps, you can write iOS apps, Android apps, and run them natively, all using C#. So these are some system-level APIs which we actually use while we create a .NET app. So we use system.net, system.io, system.link. We use all those queries that you do on a collection and stuff like that. Now, we use all these libraries by adding them into our references, using NuGet to add them, and so on. Now, these APIs that you would use earlier in your code, you continue to use them while you write a Windows app as well, using Xamarin. So you have specific libraries specific to that device for Windows Phone, or Windows 10. You can leverage that along with the .NET libraries that you see below in gray. Same works for iOS as well. So you have the iOS libraries like the map kit if you're using the map, UI kit for building your UI storyboards, iBeacon if you want to use a beacon BLE-based scenario that you're building with iPhone, core graphics, core motion. All these are native APIs that iOS gives you as a developer, which you can leverage with C# and then get to use all the comfortable libraries that you would be using, for example, JSON.Newtonsoft, right? JSON-Newtonsoft, if you're using for parsing the JSON, serializing, deserializing JSON objects today in your .NET apps, you continue to use that even when you go on iOS or Android, right? The best part, C#, async calls that you do, right? All the async methods are available on Android and iOS as well, which is pretty cool. While you build app, you think about how you can make the UI more responsive. Async is the best possible way, which is available across, right? So you can use those beautiful stuff on all the three platforms. Same with Android. You get to access the native interfaces through this. And you can do literally anything that you would do with Objective-C and Swift with Xamarin as well. So you can do anything, nothing special there. You can do everything here within the Visual Studio. Now, how the performance is native is on Apple platform, while you build an app for iOS, they want you to do a ahead-of-time compilation. They don't want you to generate some real-time code and stuff because your app might do what's not supposed to do. So what they do is they ask you to do a ahead-of-time compilation, and that's what Xamarin does over there. So it generates your IPF file, doing ahead of time compilation, and it binds all the native calls that you have to make, say mapkit, UI toolkit, and stuff like that with C#, and you get to use your .NET base class libraries for your ease, and so that you can create a class library and share it across Android, iOS, and Windows. We'll see how the sharing goes about. And in Android, it does a JIT, just-in-time compilation, using the intermediate language, and then it generates an APK, and then using the IL and JIT, it kind of runs natively on the app. And this is the cool part. It's always up to date. So the day iOS announced 3D Touch on the new 6S phones, right? This API before, around 6 months before, was available to actually use it in your apps through Xamarin, because you have multiple channels like alpha channel, beta channel, stable channel with Xamarin. They also work very closely as part of the Apple developer program. So it was available before. Actually, they started supporting the day Apple announced that API, when the phone was launched. On the same day, Xamarin started supporting the 3D Touch API within C# code, right? So that's the beauty here. It's always up to date. And actually, this is a fact. When Android 4.4 was launched, after 1 week of the launch, only 1% of the Android users had updated themselves. Only 1% in case of Android. In case of iOS, within the first 2 days of a launch of a new version of, say iOS 9 or iOS 10 is going to come up, within 2 days, they have around 70% iOS users moving to the update. So you see how different the users are on iOS versus on Android. Android, the updates are slow, in terms of user updating their operating system. Many times it's because not all vendors would push the Android updates as soon as they get, so the cycle takes a much longer time. In case of iOS, since iOS controls this, Apple controls this, it goes in right on the day when they announce a new release. So that's where, if you want to write an app which is always updated, which uses all the new APIs that a platform launches, Xamarin is always up to date. So you can always cater to those people on the iOS world who require you to use all the latest and the best features of a platform. Okay, now the code sharing piece, all your code that you would write, you would share it as a portable class library. You can also share it as a shared project, and you can use NuGet within the PCL, add all the libraries that you currently use in the PCL, and refer this PCL in your Android application or your iOS application. You also get to write, use a shared project. So if you have developed for, say, Windows 8.1, Windows 10, we have a new concept of shared project where you can write all the code. All the code is shared with all the referenced projects, right? Now, there are different use case scenarios when you use a PCL versus a shared project. Shared project, you have to write hashif, say, iOS. So you have to be particular about using those statements to check whether this piece of code is running on iOS or Android. Because what shared project does is it just copies all the code from your shared project into your referenced project where you are referencing this code to, and then builds it, right? So if you, by chance, miss to do a hashif Android or iOS, it's probably going to fail over there. So both are good. Whichever your team is more comfortable with, you can use either PCL or shared project. Now, this is some stats from the current apps which is available on store on Android and iOS. And you can see the amount of code that they are sharing across 2 platforms, 3 platforms, actually 3 and 4 platforms. So all these apps are available for either 3 or 4 platforms. And the amount of code sharing is huge. If you go with Xamarin Forms, you can even share code up to 100%. So we'll see a Xamarin Forms app as well. Let's now check out the development experience to start with, and then we'll come back to DevOps and stuff like that. Now, you can use Visual Studio, and you can use all the features that you would get on Xcode, say storyboarding. You can use it within Visual Studio. If you don't have a Windows machine, like if you work on a Mac, you can use Xamarin Studio, which is also available there, and you can use storyboarding through Xamarin Studio as well. And then you got to probably use for Android, they use for the UI, they use AXML, kind of XML for building the UI. You can edit that as well. So you'll get a beautiful UI previewer for your AXML files. You can preview those UIs and stuff as well here. Okay, now these are some new features using which you can actually debug, run your iOS app on a simulator, and still actually run it within Windows, not on Mac. So I'll come back to you. So to those things, I'm not sure if we'll have enough time for that. So now let's get started with Visual Studio. So let me. Okay, you guys can see my screen. So what I'm going to show you now is an interesting app that we recently actually built, and this was showcased in the build. It's known as My Driving App, and it's a well-blend scenario between IoT and mobile app development. So in this app basically lets you track your car details that you get from an OBD port. If you have an OBD2 port in your car, which most of the cars have, you can buy an OBD2 adapter, plug it into your car, and then using this mobile app, read the data from your car and upload it to the cloud. So I'm going to show you this app here, My Driving App. So this is an Android phone, and this is how the app looks like. It's complete native, so it uses, you can see it's a Google map and it's not running on a web view, it's a native map control. And then it uses the native controls what Android offers you, right? And then you can see all your past trips. You can check out your profile. Now, profile uses a lot of things on the cloud. It does use machine learning as well. So if you want the whole source code, this whole source code is available on GitHub. And if you know, over more and more trips that you would do, record, it would actually go through your trips, and it'll go through different stats like your fuel consumptions per trip, your hard stops, like you suddenly put a brake, even that is captured, and it's readable through the OBD2 port. Then the hard accelerations, total trips, and so on. Now, it's a native interface. You can see it's a templated list view control, which you can see over here. And then I can go back to my past trips as well. Again, it populates a list with the map UI. I can go back to a trip which I had done back in India, and it takes you to this trip, and you can completely, since it captures with the lat long, the current car stats, so you can actually roll back in time and see you know, where you were, what was the duration of that stop, the kilometer per hour that you were at that time. So, you know, it's a pretty bad traffic there back in Bangalore as well. So you would see my speed never went above 60 kilometer per hour. But this is how it does. Now, the cool part is this is just for you. You can use this for free without having to pay anything. All you have to do is go to GitHub, search for My Driving App. I'll show you the URL. And download this, and you can build this for Android, iOS, Windows, anything, right? We'll look at the source code next. And also, it has a feature, we talked about Hockey app, right? How about if a test user wants to give me a feedback, right, in those scenarios? So Hockey app is included in this as well. I'll show you a Hockey app integration in another app that we have added that. So first, let's have a quick look at the source code of this app. Now, all the source code is available for you free of cost. So you can see this is how a structure looks like. You would have a portable class library here, which basically contains all my codes. It has the helper methods that I would have written here. It contains interfaces that you would have created, any model that you would have created which you want to share across all the 3 platforms. Generally, the settings button contains a model which is same across all platforms. That doesn't require a customization. So you would put settings in here, your services that you are using. This connects to IoT Hub to push the data that it captures from the car along with the lat long to the IoT Hub. So it has a connector, a C# code written in here to connect to the IoT Hub. It has OBD data processor, because once you read the OBD data from the OBD2 port using BLE, it's not in the right format to be sent as it is to the IoT Hub. So you might want to format that, and for that you might want to write some code which is shareable in this PCL. Timer methods, just to check you are not sending wrong data of a different timestamp and so on. So there's a timer method here. And similarly, your view models, which is pretty important. So all your view models, you're sharing that in a PCL, which can be leveraged in Android, iOS, and Windows, which is pretty cool. Now, you will have a native Android, iOS, and Windows projects. In this project, you will write any specific code that you want to do for that platform inside this. So that is what this contains. And if you are an Android developer, you would find it very familiar. Any Android developer would find this project structure very familiar, because you have activities, you have things like resources, which is what you find in an Android native project when you use Android Studio. So you can find all your activities in Android. How it works is when you start this app, every page works as an activity. So that's the activity that you have to write your code inside. And that's exactly all the activities that this guy contains. So in this app, we have used, as I said, Hockey app. And it's a small feature within the Hockey app. Example, I want to pass a feedback about this app. A user wants to pass this feedback. So, oh, sorry, I'm not showing you this. Yep. So this is the app, my driving app. Now, what happens is, all of a sudden, I might have a feedback to pass. So I can plug in the API from the Hockey app to actually pass a feedback. So I don't have to build, say, a backend service to capture these inputs. So what I've done right now, what we have done here is, on the shake event of the phone, capture that feedback and send it back. So for example, I shake this phone. Now what happens is, there's a UI that gets populated. Now this UI is never written by us for any platform. This comes from the Hockey app SDK, this particular activity. And you can type in your name, email, subject. You can even attach a picture and send it back to the user. This is how your testing DevOps becomes much simpler, because you can give feedbacks directly to the developer without the app being on store, right? Now, how do you add this code? So in Android, you have the base activity, which you use for all the activities that you build on top of it. So in the base activity, you can just go ahead and add onShake method, right? Whenever there's a shake, it comes right here, and you can see the Hockey app being used here. Hockey app.feedbackmanager.showFeedback activity. Now this feedback activity wasn't there in our code. We didn't try that. It's picking it up from the Hockey app SDK that is available for Xamarin, which we have already added in the references, and it's picking this thing up from there. So if you go and see the references, you will have the Hockey app SDK somewhere here, Hockey SDK right here. Right? So this SDK gives us a lot of features to quickly get feedback from the app, to get crash logs, reports, without you having to code for those features in your app. Right? So it's certainly a very, very good, nice tool for a developer to use. Now, similarly, you have the iOS app, and you can actually check out the storyboard and stuff. Now, since we are running less on time, let's go to the DevOps piece. I have a small app, another app here on this Android device, which is known as Patience app. Now, what this app does is, it's again a native app on Android, iOS, Windows, all 3 platforms, and it kind of keeps a list of all the medication that a patient needs to take for a clinic. So basically, this is a pharma clinic app, which you would give it to a patient. while you prescribe him some medicines. So he can keep a track of it. You might know Scott Hanselman. So this was his demo in the build. And you can actually go ahead and select an appointment through this app, click on this plus sign. It'll bring a native interface. You can select which doctor you want. And then you can select a particular time slot here, and then go ahead. I'm not going to book that, so cancel this. And this pulls up your data of your medication that you need to take every day, once in a day, twice in a day, thrice in a day, and stuff like that. Now, in this, from a DevOps perspective, let's leave the dev piece here. DevOps perspective, imagine as a developer, I have done a mistake. I've put home screen on the top. Now, this sounds crazy, home screen. Maybe as a developer, didn't matter to me, so I just kept the activity name as home screen, which is activity title name. Now, which looks a little odd, because while you put this app in our production, so my QA guys might come back and tell me, it's not going to work as a home screen. It should be home, or maybe just do a welcome over here, right? So as a developer, I will go back to my Visual Studio over here. Now, this is connected to VSTS, and in that, I see the code over here says home screen, so I'm just going to change this code to maybe welcome, and save this code. And once you save this, you can actually go ahead and push this update. So I can right-click, say commit, and say updated home screen text, and click on commit. And just do a sync, because it uses Git behind. So it first updates your local Git repo, and then you're going to sync it with the master, which is on the cloud within the VSTS. So it syncs it up with that. Now, with this beautiful event that we did, something started behind in the background. Now, what is that? Is I have configured the Visual Studio Team Service. This is how the UI looks like. In the Build tab, I have configured a continuous integration, which is like pretty awesome, because the moment I check in a build, it builds it, and then it makes it available as well for deployment. So now what this guy does is, if you look at build and queued builds, you would see something happening over here in the queued piece. These are the builds which were completed earlier, right? And the failed builds, all those details will be here. For some reason, it's not yet queued. Oh, sorry, I haven't pushed it. So I'm pushing it to the remote repo right now. I just did the sync, accounting object successfully pushed. Now, the moment it's pushed, within a few seconds, my build agent will understand that there's a code check-in, or there's a change, and then let's start building it, right? So you can have build environment either hosted locally or on the cloud. You can use either of them, right? On the cloud, you pay for the minutes that you use to build. On home-prem, you save that minutes, right? So you see something started over here with a play button. Now, this build auto-triggered itself. We call it continuous integration. Now, look at the whole DevOps cycle. It's so damn fast that I do a check-in, it starts building it, generates an APK file, and then pushes it to release, which might be using a hockey app, pushes this release through the hockey app to all the users. Now, you can go and see all the details here. Once you double-click on it, it will show you the status of this build agent, where it's running, how long it's been running, and stuff like that if you want to debug it. Now, on the left-hand side, what you see is all the process that this build, as part of this build, while I configured it, I have done a NuGet restore, right? So the NuGet restore happens in VSTS on the cloud, and then it does build your application. It does all the stuff that you would see. So if you want to configure another stuff in between the build action, you can do that, right? So while it happens, after this, it will be queued up for a release, right up here, and then you will find a release 4. And once you see the release 4, you can come back to your Android app. We have a hockey app over here. So right now, I have these two apps, which is available through my hockey app account. So if I want to add a new user, I just need to add his email ID, and he will also be able to see it. This is a patients app. And the last build that I did successfully was maybe 3 or 4 hours before. So you can see it's in beta. You can see the history of all the apps that has come through this hockey app. And you can see the last build was done today morning at 10 while I was testing it from the hotel, this app. Now, since this build is in progress until the time it comes to release. Release is also going to take a few minutes. And since we are out of time, but this is how the configuration looks like. You can configure your build actions, your release actions, and in the release action, I've selected Hockey app as the output of this APK. So this APK file is going to get copied into a Hockey app account, and it's going to be available to all the users through that, right? So first, we should let the build complete. Let's check if the build is done. Nope, it's still in process. So it generally takes like 4 to 5 minutes. What's happening is I have not used a default build agent on the cloud because you have to pay per minute that you use that build agent for. So I have done a local build host, which is running on this machine itself. So all the building that happens, anyone when they check in the core, it gets built on a common machine because that's what you want to do if you want to save some minutes of the build time that you would do on cloud. So that's what I have done. And hence, it depends on internet connection because the building and then the final binary is being sent back to the cloud, right? So it's going to rely on the internet a bit over here. So maybe in a couple of minutes I can show that to you, but I think we are out of time here. Any one of you has any interesting questions? Any questions that you can think of? You can think if you are coming from an enterprise, this is a boon for an enterprise where using a single VSTS, you can manage all your cross-platform app development, sharing the code between them, and then configuring them with tools like Hockey app to ensure you get constant feedback of those apps and so on. It's so yet not completed the build. So this was the final demo that I plan to show. So this is the console that opens up, which tells you which stage your build is in. Okay. It connects to your build agent, which might be running remotely on the cloud or on this machine. In this case, I'm running the agent here on this machine as a Windows service to build this app. So once it's done, it'll automatically get released to the Hockey app, and through my mobile app, I will be able to update that app and see the stuff. Now, my whole DevOps time of a single release of the app to actually going to the QA. Now, in between, if I wish to use Xamarin Test Cloud to do some automation of test, I could have done that as well by using a small Xamarin Test Cloud plugin in my, right after my build, I would import that piece. And so after the build is completed, it'll be sent to the Xamarin Test Cloud and also with the test script that we would have written. Okay, so it's 85% done. Might take a few more minutes to do that, right? So can we also have the slides back? Slides back. Actually, okay, the things that you get, the designers, the component store where you can upload your third-party components, build, if you have a beautiful, say, API, you want to write a SDK for it and then host it through Xamarin and then make money out of it, you can absolutely do that through the Xamarin component store. There are a lot of templates that you can use to get started with, which is cool. So if you just install or go to the Xamarin website, you can get a lot of free templates, which is like complete applications, and you can start playing around with them. This is the Xamarin Forms template. So there's an app that one of the Xamarin dev evangelists did for their event, which was Xamarin Evolve. So if you search by the keyword called Xamarin Evolve on your Android store or on your iOS store, you'll find that app. You can download that. You can see how the Xamarin Forms app works, and then the performance comes as native, right? Even though it's a Forms app, so basically using the single UI controls, which works across platform, you are able to still go ahead and build a native-like app, just like a native app that you would do using Java. Right, so You also share the UI code in Xamarin. You can do two-way data binding. There are around 40 different kinds of pages and layouts that you can create with Xamarin Forms. So we will kind of skip that and maybe come back to the last. Let me show you this. This is all the Xamarin Forms code that you write. So you can write all your UI code in XAML or C#, and then this is how it would look like on Android, iOS, and Windows, all three platforms. So what this small code does is it uses a tabbed page, which is a Xamarin Forms specific page. And in that tabbed page, basically, it will map it to a tabbed control on each platform. You go ahead and write a content page because you want to put some content within that tabbed page. So you go ahead, create a content page, put a title to it, profile, settings, and then you create labels for user input within this. So if you want to create a small login page, all you have to do is just create Xamarin Form, single XAML, add 2 entries, make them, give them placeholder name, like username and password, and then create a button. So there's a button control as well. Just do a button, text name to that button. It will come over that button, and then that's all, right? And while you compile it, it will give you APK, IPA file, and Apex file, and also ZAP file for Silverlight, Windows Silverlight apps, right? Now, this is the beauty of this framework, that you can use a single XAML if you're comfortable with XAML, and then create UIs for each platform. Okay. We will skip this, and I will just share. Maybe if you can just put the last slide. Just put the last slide. So you guys have any questions? Do you see how easy it has become to actually go create mobile app, manage your whole different branches when you create a new feature in your mobile app, and then use that across different platforms and then test it out to managing your whole DevOps. So next slide. This is Xamarin University, where you can find a lot of content for yourself. If you want to learn Xamarin, this is where you go. And these are my contact details if you want to mail me for any information. Yep. Uh-huh. Yeah. Yep. 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 Mhm. Yeah. Yeah. So this is a valid question. This is coming from a dev who has actually used Xamarin Native, and then he has a question: when you use Xamarin Forms, do you get that flexibility in the UI while you build it natively for Android, iOS, and Windows specifically? Your answer to that is, as I said, if you're looking for rapid app development, this is awesome. But if you're getting into platform-specific UI customizations, right? In that case, Xamarin Native is still what you should look at, right? So to answer this question, in enterprises, most of the mobile apps is around using a web API, do a call, bind it to a UI, right? You don't spend tons of times to actually customize that UI so much. And that's where Xamarin Forms is a very, very handy approach to look for, right? So when you start a new application, you can start off with Xamarin Forms using a common lookalike UI, right? And then you can go ahead customizing, replacing it with native interfaces as you move on. So probably that's the best approach. Cool then. Sorry for running a little late.
It's fine. Okay, so thank you very much though. But this signs a very good enthusiasm